Hello, and thank you for joining us for this MDA Engage community webinar today. My name is Elise Qualley. I am MDA's Director of Program Development. We are thrilled to have you join us today for this important and educational webinar. The webinar today is part of our larger MDA Engage flagship community event series beginning in 2018 that focuses on bringing the neuromuscular community together around education and social opportunities. Be sure to check out the MDA Engage section on MDA.org for updates on upcoming in-person and virtual events. Now, I have just a few housekeeping items to go over before we begin. We are recording today's event and will be posting it to the MDA.org website for on-demand viewing to ensure that those who weren't able to join us live today are able to access the information. For those of you joining the event live, please know that all phone lines have been muted. We will be having a question and answer session towards the end of the webinar. Please be sure to utilize the chat window to type in your questions. If you hover over the bottom of your screen, a tray of webinar icons will appear. Click on the chat bubble to open the chat and enter your question to the host or to the host and panelists. You don't need to wait until the question and answer session to chat in your questions. As questions come up along the webinar, please feel free to send those in. Before we begin, I would like to say thank you to our speakers, whom you will be meeting shortly. And also, I would like to say thank you to our event sponsor, Sanofi-Genzyme. We wouldn't be able to provide events like this if not for their generous support, so thank you very much. Let's go ahead and go to the next slide, and we'll go ahead and review the objectives for the webinar today. Attendees will be able to obtain an understanding around the origins of newborn screening, learn why newborn screening is important, review how newborn screening works, hear about what MDA's role is with newborn screening initiatives, review what your role is in newborn screening, understanding newborn screening from a physician's perspective. So now I would like to go ahead and introduce you to our three speakers. Our first speaker, if we can make sure his audio is back on, we're going to check here in a minute, is going to be Dr. Rodney Howell. Dr. Rodney Howell is Professor Emeritus of Pediatrics and Emeritus member of the Hussman Institute for Humane Genomics at the Miller School of Medicine at the University of Miami. He is certified by both the American Board of Pediatrics and the American Board of Medical Genetics. He has long been active in research into rare genetic diseases and newborn screening, and is the author of more than 175 participants in these areas. Dr. Howell is currently the elected president of the International Society of Neonatal Screening, having served in many capacities over the years at the Muscular Dystrophy Association. Dr. Howell currently serves as the chairman of the board for the MDA. Our next speaker is Brittany Johnson-Hernandez. Brittany is the Senior Director of Policy and Advocacy for the Muscular Dystrophy Association. In this role, Brittany leads MDA's advocacy work across the United States to promote policies that advance the priorities of the neuromuscular disease community. She works to promote initiatives that improve access to affordable and adequate healthcare coverage and services, expand and improve our nation's newborn screening program, and to protect the rights of individuals living with disabilities. And our final speaker is Dr. Priyana Kishnani. Dr. Kishnani is Chief of the Division of Medical Genetics, Department of Pediatrics, and Director of the YT and Alice Chen Center for Genomic Research, which has a focus on developing new therapies for rare genetic disorders. She holds certification from the American Board of Medical Genetics and the American Board of Biochemical Genetics. Dr. Kishnani has built an interdisciplinary team whose efforts are most notably demonstrated by the long-standing research and clinical experience that results in FDA's approval of Myozyme as the only available treatment for Pompeii disease in 2006. So we're excited to have Dr. Howell, Brittany, and Dr. Kishnani here to take this webinar forward. So if I would like to now, if Dr. Howell is unmuted and on the line, I would like to turn the webinar over to him. And let's see, I know Dr. Howell, I see him on the screen, but I know we were having some audio issues, so let's just see if we can get him unmuted. It's going to be just 1 second. And thank you all for your patience while we work through some of the audio issues. Sometimes these webinars, we do end up having some technical difficulties. So we are just working to get Dr. Howell unmuted. All right, so it looks like we're going to continue to work. We've got Dr. Howell here. We just don't have him on the line, so we might around a little bit today, and we will come back to Dr. Howell to give us an overview of kind of where newborn screening began from. So if we could, Nicole is running the webinar from behind. We're going to go ahead and jump ahead to Brittany Hernandez's slides. If we could, Brittany, are you on the line?
Yes, I am.
Perfect. Wonderful, Brittany. We are getting to your slides, and if you wouldn't mind, I'm going to let you kind of take it away.
Sure. Thank you, Lise, for putting this together, and everybody who's on the line for joining. Newborn screening is a really important priority for the Muscular Dystrophy Association, seeing as, you know, early detection is really the key to early intervention for a lot of the conditions that on which we focus. So I'm just going to run through a quick primer about newborn screening, and then we'll give a breakdown of how the Advocacy Department at MDA is involved in its promotion, and then I'm sure that Dr. Howell's presentation will definitely serve to provide a lot of really great information on why this is so important. So newborn screening began in the 1960s. It is one of the most successful public health programs in the history of the United States. It screens every baby born for conditions, for a list of conditions that can be detected at birth, for which early intervention is key, and for which treatments are available. Generally, this screening is delivered to families, to babies within 24 to 48 hours of birth, so it's done in the hospital. It's done via a small heel prick to the baby's heel to gather a tiny bit of blood, which is then transferred to a sample paper, which is processed by the state public health laboratory. It really allows identified babies to be connected to the vital treatment and services needed to address their conditions, such as the treatments available through the MDA Care Center Network. Next slide, please. So this is just, this graphic I love. It's a really simple and easy way to understand really how newborn screening works from beginning to end. So the first thing that happens is blood spot is collected in the hospital from the baby right after it's born. It's then transmitted to the state public health laboratory, where it is screened through their testing mechanism. Once a screen comes up positive, that information is shared with the healthcare provider for the baby and its family. So that goes directly to the baby's general pediatric provider so that they can be in touch with the family about referring them for confirmatory diagnostic testing. And then once that true diagnostic test is done and the confirmatory test has come back, their child is referred to a specialist for initiation of treatment. And that's, you know, really where the MDA center network comes in with our care centers across the country that can provide that treatment to families who are identified. Next slide, please. So newborn screening for neuromuscular conditions specifically, it's an interesting place right now. So the United States Department of Health and Human Services recommends a list of disorders for which all babies should be screened at birth. This list is called the Recommended Uniform Screening Panel, or the RUSP. There are 35 disorders on it, but only 2 of them are neuromuscular conditions. One of them is Pompeii disease, and the other one is spinal muscular atrophy. Both of these conditions were added in recent years, with Pompeii being added in 2015 and SMA being added in 2018. However, just because these conditions are on that national list, the RUSP, does not mean that every baby is screened for them, because each state uses the RUSP as a guide to decide what conditions they are going to screen babies for. And so really the decision on what a baby will be screened for is really up to every state individually. And so most states don't screen for SMA and Pompeii yet because they are pretty recent additions to the RUSP. And states have to undergo, every state undergoes a really detailed diagnostic test of what they have available across their public health system, the resources that are available in order to initiate testing for a new condition that's added. So right now, the state of the states is that there are thousands of babies born every year with conditions that their states that are on the RUSP, but for which their states are not screening, and their families not know that their babies have these conditions because they don't get that really early diagnostic testing. Next slide, please. So you can see here kind of the gap that we're facing right now. So the 2 pink states are states that only screen for SMA. The purple states that screen for only Pompeii, and the yellow states that screen for both of these conditions. So really a lot of work to be done here. And MDA is focusing very hard on working towards state implementation, because it is really wonderful to see a condition added to the RUSP. But until each of these conditions are on every state screening panel, we've not succeeded, and so we're continuing our work in that regard. Why is it important? We talked a little bit about this, and Dr. Howell will really get into this as well, but for SMA and Pompeii, early detection is critical. As a lot of families in our community know, the earlier that you can detect these conditions, the better chance you have that really can stave off, the continuation of the disease and the effect that it has on babies. So really, it's urgent that families and their children are connected to expert care as soon as possible, and that's really what newborn screening allows for. That follow-up testing at the MDA Care Center Network, or the follow-up care provided the MDA Care Center Network is really what's providing a lot of the care to these families through, especially those identified with SMA and Pompeii. You can see our Care Center Network on this slide. You can go to the next slide, please. So what's next for newborn screening? It's an exciting time because there's a lot happening in this space right now. And while MDA worked really hard to see SMA and Pompeii added to the RUSP, we're now working really hard to see another condition added, and that's Duchenne muscular dystrophy. We're interested and working with partners across the country, across the spectrum, from clinicians and researchers and other advocacy organizations, to gather the information that's necessary to submit a nomination to have Duchenne considered by that advisory committee over at HHS to be added to the RUSP. As I'm sure many of the people on this call know, Duchenne is the most common form of muscular dystrophy, and early intervention, just like SMA and Pompeii, is key in order to start delivering care to patients and support services to their families. So here's what kind of a short breakdown of what we're doing over at MDA to speed newborn screening across the country. We're working on state implementation for the conditions that are on the RUSP, so that's SMA and Pompeii. We have published a number of pieces in nationally circulated journals, newspapers, and other outlets in order both to educate the community and the nation at large, but also speed policy reforms so that we can share published pieces by some of the country's most respected researchers and clinicians with policymakers to show them that there is public interest in promoting newborn screening. And we recently, one of the most exciting pieces that was recently published was a piece on newborn screening in the JAMA Neurology journal, which is a really big and well-respected publication. A big part of my job, being in the policy and advocacy department, is educating and engaging Congress and the administration on the importance of newborn screening. MDA recently partnered with March of Dimes to hold a briefing for members of Congress and their staff on newborn screening and the reauthorization of the program. As I said, we're also working on data generation in order to advance a RUSP nomination for Duchenne muscular dystrophy, and we're engaging our advocacy network across the country. So both the implementation of SMA and Pompeii on the state level, but also for the passage of the reauthorization of the federal program, which I will get to in just a moment. Can you just go back to the last slide quickly? I just missed the last point. And then the last that I'll make is obviously we're working in order to deliver the best care, treatment, follow-up to infants through our network of care centers. All right, so the federal program that allows the National Newborn Screening Program to exist is something that needs to be reauthorized every 5 years. And this current authorization under which the federal government is operating expires at the end of September. That's in a month. And we are in a situation right now where we at MDA are working very hard to ensure that this authorization is passed before that expiration. Unfortunately, we're in a situation where we don't know yet if that authorization is going to pass the time, and so we have activated our advocacy network on. There are 2 bills that both would reauthorize the program. There's one in the House and one in the Senate. The House bill has already passed, which is really great news, and now it's up to the Senate to take action. There are really important provisions in the bill to modernize the program, and it also raises the amount of money that the federal government commits to the program every year, which is really important because the amount of money that is committed is distributed throughout the states in order for them to modernize and implement new conditions like SMA and Pompeii. This new, the reauthorization bill that is being considered also commissions a report by the National Academy of Medicine on modernization of the program. Like I said at the beginning of my talk, and as Dr. Howell will address, newborn screening has been around for a long time, since the 1960s. It's an established program that's made a big difference in the lives of thousands and thousands of people and their families, but it's a big program that could use some updating and modernization. We don't know exactly what that is yet, but we know that there is room for that. And that's why MDA really pushed hard to see this study included in the reauthorization program, because we do think that there is opportunity to do more with how it operates right now. And so we're excited to have seen that included in the reauthorization. Slide. So there are ways that our community can help. The first thing that we really, really need people to do is to join our advocacy network so that you can be informed of what's happening. And it's easy to do. You just go to mda.org/advocacy, sign up for the network where you can get emails. We do a monthly update to all of our advocates to share what the advocacy department has been working on. We share a newborn screening update every single month on implementation across the country, like if a new state has added a condition or is considering adding a condition, or if they're is an opportunity to take action on the state level. And then we also have an opportunity for all of our advocates across the entire country to take action to encourage the Senate to pass the Newborn Screening Saves Lives Reauthorization Act. And so if you go and sign up for the Advocacy Network, you'll both sign up to get emails, really important, critical updates about what's happening across the country. And you'll also have the opportunity to send an email to members of Congress in order to encourage the passage of this really important reauthorization program that will allow the nation's newborn screening program, not just to continue, but to really be improved in order to serve even more families for years to come. Next slide, please. Thank you.
All right. Perfect. Thank you, Brittany, so much for that great information and for sharing everything that's happening right now currently in the newborn screening space. So what we'd like to do now is I'd like to ask, we're going to try to unmute Dr. Howell if we could. So I'd like to ask anyone who has called into this webinar, if you could please right now go ahead and just mute yourself for a moment manually on your phones. Dr. Howell, if you please make sure your phone is unmuted. Nicole's going to go ahead and unmute all of our call-in folks manually on the back end, and we're going to see if we can find Dr. Howell. So if folks could, who aren't speakers, go ahead who called in with a phone to mute themselves. And Dr. Howell, just make sure your line is unmuted. Go ahead, Nicole.
I am unmuted.
Dr. Howell, we have you back.
Oh, well, congratulations.
Wonderful. I know. I'm very glad we were able to find you. What we'll go ahead and do, Dr. Howell, is we're going to go ahead and reverse slides, and we can go ahead and get you up and running here in just 1 second.
Don't do anything that would mute me back and so forth. That's better.
No, we're going to leave you fully unmuted. So here we go.
Thanks very much and so forth. And we're sorry that we had these technical issues with muting and unmuting this morning. The purpose of my brief comments this morning is to give a little background information about why we really need newborn screening. The question is, why not just diagnose these children once they have symptoms and so forth? And I'll explain to you why that is not possible and that is not the way to go. And newborn screening began, I like to think of newborn screening as beginning about 100 years ago in Norway. And it had happened actually based on the very keen observations of a family who lived there, and that's the Eglin family. Harry was a young dentist, his wife Bjarne. They were very concerned that they had a 3-year-old daughter who was very slow in speaking. And while they were concerned about her, Mrs. Eglin recognized she was pregnant, and they soon had a son they named Dag, and he was also very delayed. Important for this observation, the family detected that both children had a very musty odor about them. And the father, who had really bad asthma, couldn't stay in the closed room with the kids because of the odor. And the family quite properly thought, well, goodness, that odor might have something to do with their delay. And so they consulted a professor who had taught them in medical school, actually in dental school, and his name was Asbjørn Frøling. And Dr. Frøling was a medical professor at that time, and he was teaching dental school during that time. He had worked on the mechanism of acidosis, and the Eglins knew him and thought he'd be a good person to ask about what the problem was. So next slide, please. Mrs. Eglin, Bjarne, brought a variety of urine samples to the Frøling laboratory, since Dr. Frøling had requested her to, and one of the routine tests that was done at that time for chemicals in the urine was a ferric chloride test. It was actually a test for ketones, and it ordinarily with excess ketones, which they were looking for in the usual situation, caused a brown color. But when we tested these children's urine, it was a dark green color that faded in a few moments. And the question was, could it be diet or herbs or things of that nature? And all those were eliminated. And so Dr. Furling then asked Mrs. Eglin to bring in a lot of urine so he could work on isolating whatever compound might be in the urine. Mrs. Eglin was very diligent. She brought 20 liters, 20 gallons basically, of urine to the laboratory. And he, with the laborious process, ended up precipitating and working in the urine. He identified the material in the urine that was causing the green color as phenylpyruvic acid. And he felt that that was likely to be related to the situation. He then went to an institution to see if it was just a funny situation, and went to an institution with mentally delayed children, and he surveyed several hundred children, and he found positive ferric chloride tests similar to what he saw in the Eglin in 8 of those children. And so all of those children were significantly delayed, and he termed this condition phenylpyruvic, purely found in the urine, oligophrenia, which simply means low ability. And he, of course, detected it was an abnormality of phenylalanine metabolism. And he published that result in 1934. Next slide, please. Now, the children that were identified with this delay were profoundly delayed. And this is a very old slide, as you probably recognize, with early children. And you can see that the average ability of these children was under 20. So that these children did not develop speech, they were not toilet trained, and so they were profoundly delayed. This was not a modest delay. Next slide, please. And he had identified it was an abnormality of phenylalanine metabolism, which is shown in this slide, and don't trouble too much with the chemistry here, but he detected that they had an elevation of phenylalanine, and phenylpyruvic is a breakdown of elevated phenylalanine, is a defect in converting normally available phenylalanine to the other amino acid, tyrosine. Now, phenylalanine is an essential amino acid. It means that we don't make any in the body, and all the phenylalanine we have comes from diet and so forth. So it was perfectly clear to think about, well, goodness, we should be able, if phenylalanine excess is the problem, we should be able to reduce that and perhaps help the children. Now, at the time these observations were being made, Europe was sinking rapidly into a devastating World War II. This was in the late 30s, about these observations was made, and not much happened in exploring this situation until after World War II. And the next big breakthrough occurred with a German scientist who was on sabbatical in the UK named Horst Bickel. Next slide, please. So Horst Bickel decided that he would try a diet that was low in phenylalanine. He tried this in 1951, and interestingly enough, it's fairly easy to get phenylalanine out of broken down protein, hydrolysate, by adding activated charcoal. And interestingly enough, a little side comment to this first thing, the chemist who was aware of how to make this diet was a very distinguished chemist who worked at Ormond Street in London and at Oxford University named Dr. Lewis Wolfe. And interestingly enough, Dr. Wolfe later retired to Vancouver, Canada. I'm going to present him an award next week for recommending how to make this diet. I'm presenting it to Dr. Wolfe next week because he has just celebrated his 100th anniversary. A remarkable discovery. Anyway, Bickel tried a profoundly delayed child on this diet who had a very high phenylalanine, and the child clearly improved. It was obviously that, and so forth. So you had a very difficult diet, a very difficult situation with profound delay in children, and you now had a clue as to how you could treat it. That is by giving them a diet that was deficient in phenylalanine. And so the problem then was phenylketonuria, or phenylketonuria oligophrenia is an autosomal recessive disease as far as inheritance is concerned. And these families rarely have a previously affected child. So a family would not know that they had an affected child. And the evidence that Bickle had in this child was that in treating a child 26 months of age was too late. In other words, the development of the central nervous system that had occurred in the first couple of years of life had proceeded before you knew the child had the problem, and therefore you needed to diagnose the person at the beginning of life. And again, that means that in families, there's no family history. You need to diagnose the baby before they're sick or before they have symptoms. So you would need to have a test that you could apply to everybody in the population. Huge order and so forth. And the test would have to be cheap and reliable and available to test every baby born. And so, next slide, please. The clever guy that came up with this was a wonderful pediatrician immunologist in Buffalo, New York, named Bob Guthrie. He was working at that time on amino acid nutrition in cancer, and he was testing small samples on a plate. So what he recommended was to collect small dried spots. As you see, this is a piece of filter paper you see in this photograph, and on that filter paper are little spots of blood that are dried, and he recommending collecting spots on dried filter paper. And next slide, putting those spots, this is a Pyrex dish, and this is Bob Guthrie here. You know, Pyrex dishes are clear, and he was using a Pyrex dish that had an agar in it, which is kind of a gelatin material. And in that agar, there were spores of a bacteria that required phenylalanine for growth. And if you punched out these little discs, put them on the surface of this jello-like material with bacteria in it, and if there was a lot of phenylalanine, you got growth. You can see up in the left-hand corner here, you can see a halo around one of the spots. That meant that that spot had a lot of phenylalanine in it, and it ran out into the jello type stuff and caused the bacteria to grow, whereas normal amounts of you can see around the other spot didn't have any growth. Now, this seemed like an unbelievably simple test, and many of us were concerned that probably wouldn't work, but it worked very well. Next slide, please. So large numbers of babies were screened in the newborn period. Again, a very old slide. This slide is 50 years old. This is a group of 43 children who were diagnosed in the newborn period with phenylketonuria using this dried blood spot that Bob Guthrie had developed, test, and so forth. This is the plot of the intelligence, and you can see that these children had moved almost over to the normal range of intelligence. And this was just at a time when the diet was being experimented with and it was not well developed. And over time, it was clearly shown that children with phenylketonuria who were diagnosed and treated in the newborn period end up with complete normal intelligence. Next slide, please. This became such an important thing that all 50 states very soon started screening every baby born. It's a public health program run through the public health departments, and it started originally with phenylketonuria because it clearly was dramatic. It took folks who from abilities of under 20 and put them back in the normal range. Rarely do you see anything so dramatic in any part of medicine. But over time, people said, well, goodness, if it works for phenylketonuria, what about hypothyroidism and other conditions? And so you had the states adding different tests to their screening programs and so forth. And as these programs grew, there was extraordinary variation from state to state. And that's a real problem with a society that moves around so much. So you see the next, and this became, this is a little paper that's from Washington, D.C., and this is in the early 2000s, and you can see that this became a real problem. And in Virginia and the District of Columbia and Maryland, you could drive 15 miles from these three areas and have three totally different screening programs. And if your baby was born in one state and had a condition that was diagnosed in the newborn period and treated, and you were pregnant again, you can see what a problem that would be. So there was a tremendous public interest in developing a consistent way of deciding what you screen for in each state. Next slide, please. So the American College of Medical Genetics had a contract with a federal organization, HRSA, and they were charged with looking to do an evidence-based review, not just because you think it's a good idea, but to look at the scientific and medical evidence and decide what should all babies be screened for. And basically, it was a very distinguished group of scientists and physicians, public persons, legal people, and families. Worked on this for a couple of years. They solicited outside input, et cetera, and at the end of the time, next slide, please, they came up with a recommendation. Next slide, please. And this is and they came up with section criteria for a uniform panel. This is the cover of a volume of Genetics in Medicine that was devoted to this study. And basically, fundamentally, these are all practical reasons that you would want to screen a baby. A serious condition, you have a reliable test, you have an effective treatment, and you can make a very big difference. So the other things that are here and so forth. And the next slide, please. This group, at the same time, reported their efforts to the Advisory Committee on Retinal Disorders in Newborns and Children, and Brittany has already spoken about that group. This committee first met in 2004 and reviewed, focusing the charge to the federal committee under federal law. The charge to the committee is broad, but to date, the committee has really focused on screening. And I had the privilege of chairing that group for the first 8 years of its existence. Next slide. This was they recommended, this is again in 2005, they recommended that all babies in the country be tested at birth for 29 diseases. It was such a big issue that it appeared on the front page of the New York Times, probably the only time that we'll see the newborn screening on the front page of the Times. But it simply pointed out that this was a big deal. And since that time, there have been additional nominations to the committee, and they've considered many conditions, but since that time, they have recommended that Pompeii disease, severe combined immune deficiency, cyanotic congenital heart disease, X-linked adrenal leukodystrophy, MPS 1, and SMA be added to the uniform screening panel, which is now called the RUSP. Next slide. I want to make a very important point about phenylketonuria, the first condition that was on the panel. I pointed out that the children and the youngsters that I saw when I was at Johns Hopkins, remember one 17-year-old boy who had never spoken, was not toilet trained, and required 24-hour attention, etc. And now I'd like to point out a friend of mine who is a physician, a medical specialist. He happens to be an otolaryngology specialist, but he is graduated from both dental school and medical school with honors, has been practicing as an excellent physician for many years, and without treatment from birth, he would have had an IQ of under 20. So we're talking about moving people dramatically. The Public Health Service has recognized the importance of newborn screening, and the CDC pointed out that it was one of the 10 great public health accomplishments from 2001 to 2010. So the entire screening program has moved rapidly and well, and so it's now moving along, and I think we'll now move along to our final presentation.
Perfect. Thank you so much, Dr. Howell. That was very informative to learn about newborn screening and how it came to be. And we'll now move, over to Dr. Kishnani. Are you on the line, Dr. Kishnani?
I am.
Perfect. Take it away.
Wonderful. So it's a hard act to follow after Dr. Howell, but what I was tasked to do was really on the lessons that we have learned and what we understand today since Pompeii disease was added to the record form screening panel. Next slide. So I think for this audience, we know that Pompeii is a continuum of disease spectrum, and that at one extreme we have the infantile form where the babies are have a cardiomyopathy and they present within the first 12 months of life. These are who we call classic infantile Pompeii disease. And then we have the rest of the clinical spectrum, what we call late onset Pompeii disease. But this really involves childhood presentation, juvenile onset presentation, as well as adult presentation. And typically, we've considered this a symptom onset of greater than 6 months of age. However, one thing that we have to recognize and understand is that the late onset form typically does not have cardiac involvement in the form of cardiomyopathy in the first year of life. And I think with time, we are recognizing a more broadened phenotype of these patients. Next slide. So is there variability in Pompeii disease? I think this becomes a very important question because if you have a family history of Pompeii disease, a question often comes up is, will the next pregnancy, if it's affected, look the same or not? So if there's a baby with classic infantile Pompeii disease, then a subsequent pregnancy, if it's affected with the same 2 genetic mutations, will really have no clinical variability. And I think the take-home message here is because there is such little to no enzyme that is missing in Pompeii disease, which is the acid alpha glucosidase enzyme, that it does not allow for any phenotypic or variability in how that baby would present. And so we had embarked on a study looking at siblings with the classic infantile form of Pompeii disease, and our conclusions were that there was very little variation across these siblings with infantile Pompeii disease. Next slide. So now the question is there variability in late onset Pompeii disease? And as I even mentioned earlier, they can present from the first year to as late as the 6th decade of life, and that their diagnostic delay can be as delayed up to 20 years. But one feature that we are learning in the US is that there is a common leaky mutation, which we call the IVS splice site mutation. And this accounts for at least one of the 2 genetic changes in individuals with late onset Pompeii disease in the order of 60 to 90%. So there's a very high likelihood that if someone in the United States has late onset Pompeii disease, at least one of their genetic changes will be this leaky IVS splice site mutation. Now, it was traditionally considered to be a more benign course, a milder course, but I will start to show you the advent of newborn screening, how much we are learning, and now we are seeing a completely different clinical course. Next slide. So these are 4 videos of children and or adults with what we say the late onset form of Pompe disease. And if you can click on it, I think the other two will play. I think the point here to make is that all of them carry one of that leaky IVS splice mutation, and then of course, second mutation. So again, the point which we see even from a clinical perspective is that not only is there a difference in the age at which these individuals present, but also how they present. Next slide. And so the natural cause of Pompe disease, I think, is one, if you see the cartoon there of the circles, each of them represents the muscle. And so to the extreme left is healthy muscle, and to the extreme right is damaged muscle. And the point to make is that what are the little brown circles inside are the individual muscle fibers. And so these muscle fibers together make up healthy muscle. And what's in yellow is the lysosome inside which the enzyme that's missing for Pompe is normally or should be present. And so when it's missing, there's buildup of the material glycogen, which are those dots which ultimately come out of the lysosome and then results in a damaged muscle. The rate at which these muscle fibers end up with damage is variable, and the number of muscle fibers within a muscle also vary. And so a neighboring muscle fiber can be completely normal and one can be completely damaged. So the point is that if we are able to identify patients early at a point where we can reverse the muscle damage, I think we can have the most significant impact when there's a treatment, as we do have it now for Pompe disease. Next slide. So as I think all of you here know that the treatment was approved in 2006, and we know it as L-glucosidase alpha, and in the United States, it's called Lumizyme, and it clearly has changed the course of patients across the disease spectrum. It's life-saving for those with infantile Pompe disease, and it has improved or stabilized the patients with the late onset form of Pompe disease. Next slide. So this is really as a reminder of the impact of this therapy. Just after 12 weeks of receiving the enzyme, the heart really just starts to improve quite significantly, and there's not as much glycogen buildup in the heart muscle, and the heart typically normalizes after receiving enzyme treatment. Next slide. And so the point again here is that if you initiate treatment at various stages, your outcome is going to be dependent on the stage at which a baby was identified, at least with classic infantile Pompe. So to the extreme left is a little baby that we had identified at 4 months. The one in the middle was one that was picked up at about 6 months, and then the one further on to the right is one that was picked up at around 11 months of age, and they all received enzyme replacement therapy, but you can see that the outcomes are very different. And I think this was our first lesson of the role of early diagnosis and getting the muscles at a point where we could reverse the glycogen buildup and reverse the damage, and that timing was of essence. Next slide. What we've also started to learn is that despite the enzyme treatment, we still do have persistence of muscle involvement, also some cardiac issues or heart issues that are unfolding, including scar tissue in the heart muscle as well as heart rhythm disturbances. And then, of course, a series of muscle areas that are not completely resolved with enzyme treatment, including eye muscle weakness, still a proximal muscle weakness, and also bladder and bowel issues. Next slide. And the point is that we now have a treatment, we now have a method of identifying these patients by a dried blood spot or through a blood-based assay, and so our turnaround time is pretty quick. But how good are we at making that diagnosis? And so this is data from the Pompe registry. And you can see that for the infantile form, we still have a 1.4-month delay from the median age at symptom onset to the median age at diagnosis. And this continues across the disease spectrum. And if you can see the second arrow there, that's not 12.6 months, that's 12.6 years. And so children who do not have heart involvement but present with a developmental delay or delay in achieving motor milestones often have a 12-year diagnostic odyssey. And then if we look at those who are older, they have a median age of delay of about 6 years. So this, to me, is unacceptable when we have a treatment, and also when we know that when we delay the treatment, that the outcome is not as good. Next slide. And so Taiwan was the first that embarked on newborn screening. And the data from Taiwan, I think, really helped us build a case as we were nominating Pompeii to be part of the recommended uniform screening panel. Yet there were differences from Taiwan, and I'll try and go through them. So if you see the first, those who were picked up by newborn screening are on the left-hand side, and that was N equals 5. And then those who had been clinically detected is N equals 9. You can see when we looked at survival, just how many of the babies were alive. There was 100% survival if someone was picked up by newborn screening and had infantile Pompeii disease versus 89% after 24 months. And then when we looked at a higher bar, which is the ventilator-free survival, that is not only is the baby alive, but is also breathing on its own, you can see that 2/3 of babies who were clinically detected were vent-free, had a vent-free survival versus 100% that were diagnosed by newborn screening. Next slide. And so this was the long term as these children were followed. It was very, very clear that, yes, they did have still some persistence of findings, but it was very, very different in terms of how these children looked as compared to someone who was picked up clinically. And the conclusion was that early diagnosis and treatment leads to a better outcome. Next slide. And then there was a more recent publication from the group Taiwan. And because in this island, there were 2 different hospitals and programs that were looking at it. So one group initiated treatment. If you look below, that's the Chen et al. They initiated treatment for those with infantile Pompeii disease at 21 days. And the other group, Yang et al., initiated treatment at around 12 days of age. And now if you look further at the circles, age of independent walking, the cognitive score, CPK, which is a marker of muscle damage, you can see that there's a lot of difference, even with a few days of delay in terms of initiation of treatment. So someone who was started on treatment at 12 days walked at a younger age and had lower CPK levels than someone who was even initiated, although they were all picked up by newborn screening if they were just treated a couple of weeks later. Next slide. Then the real elephant in the room is, what do we do with late onset Pompeii disease? Because I think there's a misconception that individuals with late onset Pompeii disease only present late in life. And so what is the point of identifying them by newborn screening? And so here comes the data from, again, the group in Taiwan. And there were 13 babies that were picked up with later onset Pompeii disease. And in this 4-year follow-up period, these infants were followed every 3 to 6 months. They had physical exams as well as monitoring of blood work, including the CPK. Now, out of these 13, 4 of them ended up receiving enzyme treatment. The age range was from as young as 1.5 months to 3 years of age. So once again, making the case that those with late onset Pompeii disease actually can become symptomatic and can require treatment intervention within the first few years of life. Next slide. And so there were a number of other lessons that we learned from newborn screening. Number one was the importance of doing the mutation analysis because we now are identifying what's called a pseudo deficiency allele. And the word pseudo, really, as it points out, is not real kind. So it's a lowering of the enzyme activity, but this lowering is something that is in vitro or in the test tube. It's not really low in the individual in the sense that it's not really resulting in a lowering of the enzyme activity so that the individual would manifest with Pompe disease. So it's like a false low of the enzyme activity, and it's caused by certain genetic variants in the gene. So this now has become more of an understanding, and about 4% of the Japanese population and the population in Taiwan is homozygous for this change. And what we're also noticing through newborn screening efforts now in the US is that in Missouri, we were finding a large number of patients who also carry the pseudodeficiency allele. So these would have been falsely called Pompe disease if we had not done the mutation or the genetic analysis of the gene in these patients. Next slide. And so for newborn screening development, I think you've heard this from our previous two speakers. The backbone is that we need to have an enzyme assessment, which can be done on a dried blood spot. And there are different platforms that are available. One is using the mass spectrometry, and the second is using a platform called the microfluidics platform. And there are advantages and disadvantages to each one of them. And I think what we need to point out is that the labs need to determine which platform they would like to use based on their budget, based on their space, based on their expertise and their want. Next slide. So as Dr. Howell pointed out, Pompe was added to the RUSP, or the Recommended Uniform Panel, in 2015. And this has really allowed us to get a bigger understanding of Pompe disease. And so we felt it was a responsibility to also have a guidance document for the pediatricians and the geneticists, like myself, how to manage a case that was picked up by newborn screening with Pompe disease. Next slide. And so this is the state of the status of Pompe adoption in 2019. The orange are the states where there's universal screening going on, and so these are 19 states. And as you can see, is that in the 4 years since it was added to the RUSP, that more and more states are adopting and adding Pompe to their panel for newborn screening. Next slide. And so we're screening, so now what? A take-home message is that the most urgent determination is to make a very quick diagnosis to allow and initiate appropriate management of the infantile cases. And we learned a number of lessons from Taiwan, but one thing to remember is Taiwan has only a certain subset of infantile cases. So they are what we call cross-reactive immunological material positive, which means that these patients tolerate the enzyme, the lumazyme or the L-glucosidase alpha well, and they don't really make antibodies to the enzyme. And but this is a little bit more complicated because the U.S. population is more diverse. The other part is, even if you were to make a diagnosis, how quickly could one initiate the enzyme treatment, because most centers do not have enzyme therapy on the shelf. Next slide. So this was our understanding before the start of newborn screening in the US, that it's a rare autosomal recessive disorder, which means it requires 2 genetic changes, one from each parent, and that the frequency was about 1 in 40,000 births, and that the babies present in the first few months of life. And I'm going to try and show you how newborn screening has paved the way for an improved understanding, as well as about the frequency. So this is really the data as of October 2016 to January 2017, and this was in the state of Missouri, New York, and Illinois. I just want you to focus on the last line, is that in Missouri, the frequency was 1 in 9,000 births was affected with Pompeii. In New York, it was 1 in 17,000. In Illinois, it was 1 in 24,000. So quite different from what we thought was 1 in 40,000. Next slide. And so I think there are important aspects to consider in newborn screening. The most important is that we have to work together. We have different populations here in the US, and so Taiwan data was helpful in understanding the importance of newborn screening. But here we have serodeficiency allele, which the frequency of it is different than in Taiwan. There are different genetic background here as compared to Taiwan. And we have in the infantile patients what we call CRIM negative, who have to be handled differently. Next slide. So now let's assume that our respective states are screening and we receive a call and it's positive. So what are the questions we have? Number one, has mutation analysis been done, and is this a confirmed case of Pompeii disease? The second is that how do we predict the prognosis? What kinds of assessments we need to do? The third is, when do we decide to start treatment? And then the fourth is the long-term monitoring and management of these cases. Let's try and address this. Next slide. So to better enhance this, there was a supplement in it's called Pediatrics, where we have 5 articles now dedicated to newborn screening, diagnosis, and treatment for Pompeii disease. And this was really, I think, a very important addition to the literature to allow patients and treating physicians to better understand the nuances we have now with screening for Pompeii. Next slide. So then comes the question, there are some states that use DNA sequencing at the time of newborn screening. And so it's very different if you have DNA sequencing as part of the laboratory panel, or if you do not have the DNA sequencing as the part of the panel. So that is at the time of newborn screening, that is. So if you do have the ability to sequence, I think one can confirm or refute a case of Pompeii right away. The second is that we can, through these phenotypes, decide if the patient has infantile form or the late onset form. But if you do not have DNA sequencing, we're going to need to get DNA sequencing done, because this could be a false positive because it's just serodeficiency that's causing the low enzyme activity. And then in the meantime, we've got to take a decision of how to manage this child. Next slide. So I really want to hone in on the importance of sequencing, because it helps in confirming the diagnosis. For infantile Pompeii, it helps in management strategies, because if someone is what we call CRIM negative, we've got to do immune modulation. It's important to look for that if there is a serodeficiency, and is that really making the enzyme activity low? And then I think it also has genetic counseling implications, because then you're identifying other family members who may be affected, who may be carriers. So sometimes the baby has the late onset form, and then you find 2 or 3 other children, siblings in the family who also have late onset Pompeii but were just never picked up. Next slide. And so when we don't have DNA sequencing as part of the newborn screening panel, just you can keep, yes. I think then the important part is to look for cardiac involvement. And if there's cardiomyopathy present, we know that it is infantile. And then, of course, you also have to do sequencing of the gene to confirm it. Next slide. Next slide. Yeah. And so now let's take that we've got somebody who's got infantile Pompeii disease. Now we say that the baby is either CRIM negative or CRIM positive. If they're CRIM negative, we'll start immune modulation and ERT. If they're CRIM positive, they can start with ERT or enzyme by itself, or they may need to add immunomodulation depending on what the genetic changes look like. Next slide. And so this is just to tell us a little bit more about CRIM. Next slide. So for CRIM negative, this is a protocol that has been developed and is used if someone is CRIM negative, and this then prevents the development of antibody titers and can allow the particular patient to continue to have the benefit from enzyme replacement therapy. And so this is an example. So this was Ohio's first case, and this is courtesy of Dr. McCullis. And so this was a 21-day-old boy, and he was feeding well, he was gaining weight well. He was then identified to have low enzyme activity, and on physical examination, he looked pretty unremarkable. Next slide. But you can see that the chest X-ray showed cardiomegaly. And then when the mutation analysis was done, he was identified as CRIM negative. And so then he was initiated on treatment with enzyme, but also with that immune modulation protocol that I showed you. Next slide. And at 6 months follow-up, I hope you can appreciate that his heart is completely reversed. And he's now meeting motor milestones, and he's receiving his enzyme therapy. And he, although he's CRIM negative, is now immune tolerant or is not making any antibodies to the enzyme. So the biggest challenge we have is the late onset cases that make up the 80% of what we pick up by newborn screening. So next slide. Let's say now we have someone who's got late onset Pompe disease, and this is part of our own guidelines in pediatrics. Next, yes. So we say if they're asymptomatic, then we don't need to do anything. We don't start enzyme and we monitor them. But, you know, what are we calling asymptomatic? I can name someone something, but if I don't know what to look for, it does not make much sense. So next slide. So I'm going to give you a case example that was picked up on screening. So this was a late onset, and remember we started out with the splice site mutation and said that that's the most common. So lo and behold, this baby had one splice site mutation and then had a second genetic change in the gene. And earlier on, she was considered as presumed not symptomatic, but she did have, the physician, of course, did note that some increase in the CPK levels, which is the marker of muscle injury, as early as 8 days of life. Next slide. We saw her at 6 months at Duke. We saw that, you know, she had low tone and she was delayed in her gross motor milestones. She was showing some regression in her musculoskeletal abilities. She had some tightness at the level of the hips. And on the scales that I use to monitor how children are doing, this baby is somewhere around what we say the 10th percentile. So within the normal range, but at the lower end. Next slide. And then on further examination, you know, she had features that were very suggestive of Pompe disease, area of muscle weakness. Next slide. And this is her, yeah, I guess you brought it in too quick, that's fine. So on the right, you see the 6-month-old who has Pompe disease. And when we put her on her belly, she really does appear quite good. But now if you, next. Yeah, now if you see a normal baby, you start to notice that this baby with Pompe disease is not as motor developed as a healthy 6-month-old baby, cannot really weight bear with her arms extended, and cannot hold her head up as well. And also you can see that at the level of her hips that, you know, she's got some abduction and she's not as organized or coordinated as a typically developing 6-month-old. Next slide. So now let's look at her again in lying flat. And here you can appreciate that she's kicking her legs up, but now let's click. And you can see that she's still fairly delayed as compared to a typically developing 6-month-old. So one can pass this off if one does not evaluate very carefully. So next slide. So now you can see her lab parameters. You can see that her CPK has been increased. her other markers of liver or of muscle damage or muscle injury are increased. And next slide. And so then this little girl was started on enzyme treatment. And next slide. And this is her now. So very nice impact of someone with late onset Pompe disease who was now picked up by newborn screening and has initiated treatment and is looking really good. Next slide. I think the take-home message is that we are recognizing subtle musculoskeletal findings and that late onset is not exclusively an adult disease and that we can start seeing changes as early as the first year of life. Next slide. And so we need to monitor these children carefully. Next slide. And really, I want to close in by telling us what is the impact of early treatment. And so we started a little one at 14 days of age. And this was actually prior to the world of newborn screening, but this is what set me to thinking how important newborn screening is. And you can see him at 3 months. Of course, he's already on treatment. The next slide. You can see him walking quite well at 2 years, and then see him at age 7 years. He's able to run quite well. Next slide. Next. Click, yeah. So if you have someone who started on enzyme at age 6 months versus at 2 weeks of age, you can see a huge difference in their motor outcome. Someone who's ambulating and running, and another who's requiring support for walking. And if you look below, she really even cannot independently weight bear on her legs as compared to someone, you know, who's able to actually scoot over and jump over quite well. So very significant difference in those picked by early and treated early. Next slide. And where we are headed really with newborn screening is prevention based on early intervention, and you can click. So if we start treating with ERT there, this is the amount of damage that we can prevent, and we can really assist these children in doing well. Next slide. And so today, our facts after the initiation of newborn screening in several states is that the frequency of the condition is more, and that we're also realizing that the children present, the infantile form can present right at birth rather than the first few weeks or months of life, and that late onset can also present in the first few months of life, and they have an involvement of muscle groups that we see in the adult presentation. Next slide. And so with that, you know, I would like to end this presentation, but really to tell you that we've come a long way in the journey, and I think Pompe is just an example of the other neuromuscular diseases which are either getting on the rasp or making their way there. Thank you.
Very good. Thank you so much, Dr. Kishnani, for sharing. I think that was a wonderful demonstration of the impact of newborn screening. Nicole, if you could go back one slide, we're going to go ahead and open this webinar up. I know Dr. Howell, Dr. Kishnani, and Brittany have both shared a wealth of information today, and we would like to give the audience an opportunity to go ahead and ask some questions of our speakers as well. As mentioned earlier in the webinar, the lines are muted. However, if you hover over the bottom of your screen, a tray of webinar icons will appear, and you can click on the chat button to open up the chat bubble, I should say, and you can open up the chat feature and go ahead and enter your question into there. We do have a couple questions that we'll go ahead and get started with, but please feel free if you have questions to go ahead and chat those in there. The first question, Dr. Kishnani, this one might be for you. The question is, how long does it take to get newborn screening results?
The results should come back pretty quickly. So again, the question mark is if there is sequencing, which is also done at that time of newborn screening or not. But the bottom line is that within the first 2 or 3 days, you know, you can get an answer. It's now more a point of when the pediatrician is able to get the patient or the little baby in, or the geneticist get involved. But we are really advocating for this to move as quickly as possible.
Perfect. Thank you for that. Dr. Howell, this question may be for you. It says, Dr. Howell shared some of the criteria for why a disease is or isn't added to the list, whether it's inexpensive, reliable, that type of thing. Can you talk more about how this applies to SMA versus DMD versus other diseases under MDA's umbrella?
In the preparation of the RUS criteria, although cost is listed, it was not taken terribly seriously because of the fact newborn screening is, in the medical world, is one of the greatest bargains that we have. The program itself is very inexpensive, and most of the treatments are inexpensive. Now, recently, however, as we've moved into the area of molecular genetics and we have treatment that involve DNA modification, such as in antisense oligonucleotides that are one of the treatments used for Duchenne muscular dystrophy, and also one of the treatments for SMA. Those treatments are very expensive, and the gene therapy treatments that are that have recently been approved for SMA and that will soon be approved, I'm confident, for Duchenne, are quite expensive. So that one of the issues that has come up is that identifying mechanisms to pay for all of these treatments will be very important. Medicaid will cover these treatments in virtually every situation, and most private therapies do, but private insurance does. But sometimes challenges do come up, and I think one of the things that MDA can help with is to help navigate the system. MDA cannot pay for these treatments, but it can help navigate the system and provide information and support as people identify ways to fund it. As a country, our healthcare system can clearly afford to do this. We'll need to figure out how to do some of these very expensive treatments.
Perfect. Thank you, Dr. Howell. Brittany, this question may be for you. Can you talk more about what the process looks like at the state level for getting a diagnosis added to a state RUS?
Sure. So every state actually handles this in a manner. Some states require the legislature to approve the addition of a condition to their state panels. Other states, there are two states in particular, California and Florida, which both passed the law mandating that the state undertake a review of conditions once they're added to the RUS so that they can be added to those states' conditions in short order. Other states have a review advisory panel that makes a recommendation, which can then go to the governor for an executive action. But really, the long answer short is that there is no set way this happens in each state across the country, and every one of them is very different.
Okay, perfect. Brittany, for sharing that. I see one more question that we have in here, and it's kind of related to that. And Brittany, I think you might have touched on this in your presentation as well. But the question comes in is really, what can I do to help if their state does not include SMA or Pompeii on the full RUS for their state, yet it's on the national RUS list?
Right. So MDA is actually working on a kind of nationwide plan on implementation for SMA and Pompeii. And as we kind of, formalize that plan and create opportunities for outreach, we will share that with our networks in every state. But because, as I mentioned, each state is totally different, our approach to each state also needs to be unique. So it is quite a complicated undertaking, but it's something that we're pursuing. And as soon as we have action availability for our applicants, we'll share that with the entire community.
Perfect. Thank you, Brittany. Well, I do not see questions that have come into the chat window. Participants, you can always email mdaengaged@mdausa.org if you do have questions following this webinar. Before we wrap up, I wanted to see if Dr. Howell, Dr. Kishnani, and Brittany, if any of you have any closing thoughts before we wrap up the webinar.
I'd like to make one general comment, and that is the question of adding conditions to the state panel. It's very important that the additions to the state panel be reviewed by the National Committee, and the reason for that is that the National Committee conducts evidence reviews, and those are extremely expensive, and they examine all the evidence that show the benefit or the liability of adding a condition. And the committee is very, very actively interested in adding anything that meets those criteria. And so I think it's important for it to have the evidence review at the national level before one works at the state level, because I think just having the state add something that has problems, et cetera, doesn't really move the whole situation forward.
This is Brittany, and I would agree with Dr. there and would clarify for our listeners that MDA does prioritize the implementation on the state level of conditions that have been added to the RESP.
Wonderful. I think that's a good addition to add. Dr. Kishnani, is there anything that you would like to add before we close out?
No, I think that just the addition of I consider myself as an expert in the field, but I think newborn screening has definitely provided a completely new insight into this rare disease. And I think that the other patients, as they get the RUSP, are going to be teaching us more, and I think we're going to start seeing a whole new phenotype emerging, because when you have a treatment and you can intervene early, I think you can have a very significant outcome.
Well, with that, I would like to close out this webinar by first kind of thanking everyone who joined us today and listened into this webinar. And I would like to say thank you to those who will be watching it on demand. And I would like to give an extra special thank you to our guest presenters today, Dr. Rodney Howell, Brittany Johnson-Hernandez, and Dr. Priyana Kishnani. We sincerely appreciate your time and expertise and everything you do for the neuromuscular community. I also would like to just say thank you to MDA's program specialist, Nicole Petrowski, for running the behind the scenes for this webinar. And also, again, I would like to thank our event sponsor, Sanofi-Genzyme. We wouldn't be able to provide events like this if not for their generous support, so thank you very much. This concludes today's MDA Engage Newborn Screening webinar. Thank you very much for attending, and I hope everyone has a nice and safe Labor Day weekend.